Hello, everybody. Today we're going to start Chapter 3. In Chapter 3, we're going to be talking about radicals mostly, and we're going to do some things that you've done for quite some time. We're going to take some square roots, and usually you have taken square roots of numbers, and this year, we're going to have some variables underneath the square root, and we're going to do some different kinds of roots besides square roots. We're going to do something called a cubed root or a fourth root or an nth root, and it's just an extension of some things that you already know. So what is a square root? A square root is one of two equal factors, and you know that 5 squared is 25. And negative 5 squared is also 25 because negative times negative is a positive. So 25 really has two square roots if you think about it. But when we say what is the square root of 25, we are talking about the principal square root. And the principal of square root of 25 is just 5. That would be what your calculator would tell you if you were to do a square root of 25. It will always give you that principal square root. So if you want to do the square root of 25, like I showed you, you're going to write down the principal square root of 25. And if you want to make that negative, you put the negative on the outside of the radical. So it would be negative square root of 25, and that would give you a negative 5. And if you want to count, or if you want to talk about both of the square root, the principal square root and the not principal square root of 25, you just put a plus and minus outside of the square root. So plus or minus the square root of 25 is either positive 5 or negative 5. And here's an important note. You probably know this already, but if you take the square root of a negative number, you don't get a negative number in return. In other words, the square root of negative 25 is not negative 5. The square root of a negative number is not a real number. So if we took our calculator out and tried to do the square root of negative 25, see the negative is underneath the radical, and we hit enter, your calculator will say that it's a non-real answer. So if it's a non-real answer, it's not a real number. So make sure you know that. You can't do a square root. Well, we are going to really later on in this chapter be trying to take square roots of negative numbers, but for now, for this part of the chapter, you can't do that. If you want to take the square root of a monomial, look at this as a monomial, because if there's only one term, you can take the square root of each individual factor, just like you can cancel out each individual factors. You can take the square root of 9 and get 3, and you can take the square root of x squared. The square root of x squared is just x. And in this example, you have 4 factors. You have a 49 times x squared times y squared times z squared. So you have 4 different factors. You can take the square root of each individual factor and call that 7xyz. But please note that if you have a binomial, remember this is a term. Up here, these are all factors. Please write that down. These are all factors. And you can take the square root of factors, but these are each called, and we know this, we've said it 100 times in class, these are all terms. And you can't take the square root of each individual term. All right, so that's a really important message. And even some of my upper level students try to do that every once in a while. You can't do that. You can't take the square root of a term. Now the cubed root. The cubed root is a different kind of radical, and a cubed root is one of 3 equal factors. You know that 2 times 2 times 2 is 8. So if you take the cubed root of 8, this little 3 it's called the index in this little v. The cubed root of 8 is equal to 2. And since 1 or 10 to the third is 1,000, you can take the cubed root of 1,000 and call that 10. Now here's an important note. Since negative 4 to the third power, negative 4 times negative 4 times negative 4, that's going to give you a negative 64. Remember, negative times negative is negative. Then you can do the square root of the cubed root of negative 64. You can put a cubed root or a negative under a cubed root and still get a real number. That's negative 4. So the cubed root of a negative number is a real number. Let me show you how to do a cubed root on a calculator. If you press the math button and you go down to option 4. Option 4 is the cubed root. So option 4, the cubed root, if you want to take the cubed root of negative 64, the calculator will not tell you that it's an error. It'll just give you the answer of negative 4. So we're going to evaluate each one of these down here. And if you want to shut the video off and try these yourself, that would be a great idea. Or you can just listen and copy over what I'm doing. The plus or minus square root of 36 is equal to positive 6. And it's also equal to negative 6. So you just write it as plus and minus 6. But that's got two answers. The square root of negative 225, well, if you're not sure what the square root of 225 is, just take your calculator out. This is always available for you. And it's 15. So since there's a negative on the outside, this would be negative 15. The cubed root of 27, what times what times what is 27? Well, if you're really not sure, you can just take your calculator out and do the cubed root of 27, and you can see that it's 3. 3 times 3 times 3 is 27. And now we have two factors, 100 times x squared. Well, 100 times x squared, you can take the square root of 100 and get 10. You can take the square root of x squared and get x. On this next example, there's a little 2. Now, if you see a number in this index, or in this v, he's called the index. And I'm going to talk about that very shortly, about what that is. That index, if it's a 2, it means a square root. And we don't have to write it. Like up here, it's an implied 2. So you don't have to write a 2 if you don't want to, but it's not a wrong thing to write a 2. So you don't have to write it. It's implied. All right, so you're going to take the square root of 4 and get 2, the square root of x squared and get x. Now, if you take the square root of y to the 10th, you're not going to, what you're going to do is you're going to say y to the 5th times y to the 5th is y to the 10th. Y to the 5th times y to the 5th is equal to y to the 10th. So what is the square root of y to the 10th? It's actually y to the 5th. And to do this quickly, you can just divide this exponent by this index and get what the square root is. You're not going to take this, I was going to say you're not going to take the square root of 10. You're just going to divide 10 by this number. In number 6, the cubed root of 125. Have we done that one already? I don't think we have. So let's do math, the cubed root of 125, and that would be equal to 5. So the cubed root of negative 125 is negative 5. And the cubed root of x cubed, well, you can take that 3 and divide it by 3. 3 divided by 3 is 1, so this is negative 5x. You can have a fraction underneath. You can take the square root of each individual. These are all factors, factor, and that's another factor down there if you want to think about it that way. So the square root of 16 is 4. Now remember, there's an invisible 2 here. You can always write a 2. So 16 divided by 2 is 8. That's 4x to the 8th, all over the square root of 25, which is 5. So remember, you're going to divide this number by whatever this number is. And if it's not written, then you just write a 2 in there if you want to. Now the cubed root of 8, what times what is 8? I think we've already done that one today. So the cubed root of 8 is 2, and the cubed root of x to the 12th, remember we take the 12 and divide it by 3. 12 divided by 3 is equal to 4. So 2x to the 4th would be that answer. All right, now let me see if I can focus this a little bit. Oh, that's a little bit better. Now we're going on to page 2. And we don't have to talk about square roots or cubed roots. Sometimes you talk about an nth root. Well, what is an nth root? It's one of n equal factors. Instead of 2 equal factors, 3 equal factors, it's one of n equal factors. All right, so this n in this example, n is 5. 3 to the 5th is 243. You can ask your calculator. 3 raised up to the 5th power is 243. Well, if 3 to the 5th is 243, then you say the 5th root, and write that, the 5th root of 243. That's what this is asking for, is the 5th root of 243. Well, that's equal to 3. And I'll show you on your calculator you can do 5th roots also. What you have to do is you have to type the 5 in first. 5 is for the 5th root. And then you press the math button, and then you go down to option 5. That little X in there means the nth root, so hit option 5, and then that little 5 comes up and becomes the 5th root of 243. This is a good trick to know in the calculator. So there you go, the 5th root of 243 is 3. So try these on your calculator. All right, so that said the nth root of k. Now we have some vocabulary words here. K is called the radicand, and I talk about a radicand quite a bit when I talk about what comes underneath the radical. So radicand is important, and the index is called, or this little number in the V, he's called the index. So make sure you know those two vocabulary words, index and radicand. If we already talked about this on the other page, but if n is odd, if it's a 3 or a 5 or a 7 or a 9 or any odd number at all, this radicand can either be positive or negative. We've already talked about that. Like we've already done the cube root of 125. That's equal to 5. The 5th root of negative 32. What times what times what times what times what is negative 32? Well, you could ask your calculator if you wanted to. You could just pop right back up to that old whatever we just had on, and you can put negative 32 in there and do a 5th root of negative 32, and that would be negative 2. Any root of 1 is 1, and any odd root of negative 1 is negative 1. But if n is even, the radicand, what comes underneath here, must be positive, or else it's not going to be real. So the square root of 81 is 9. The square root of 625, the square root of 625, that's equal to 25. The 4th root of 625, you would hit a 4, and then you'd hit the math, option 5 button, 625, and that's equal to 5. The 4th root of 625 is 5, and the 6th root of 1 is 1, but notice they're all positive numbers because you can't do the square root or the 4th root or the 6th root of a negative number. Okay, and the last thing we're going to talk about is some rules of powers. If you have a power of a power, okay, what you're going to do is you're going to multiply those exponents. This is like x squared times x squared times x squared, right? X squared to the 3rd power, which is x times x times x times x times x times x. And how many x's have you multiplied together? You've multiplied 6 x's together. That's x to the 6. Again, if you have x squared to the 4th, it's x squared times x squared times x squared times x squared. How many x's do you have altogether? 2, 4, 6, 8. This is x to the 8th, right? That's called the power rule. So if you have, if you're asked about the square root of x to the 8th, there's a little 2 in here. Invisible. Remember, we divide this number by this number. 8 divided by 2 is 4. This is x to the 4th. The square root of x to the 8th is x to the 4th. And here's another thing. You can put a little 2 in there. If it's not written, you can write a 2. 6 divided by 2 is 3, so that's x to the 3rd. 8 divided by 2 is 4. That's y to the 4th, right? Y to the 4th squared is y to the 8th. X to the 3rd squared is x to the 6th. And over here, x to the 4th squared is x to the 8th. And then the last one. Now this one is a little bit tricky because you have an odd number here. Here's a 5. So what we're going to do is we're going to break this up a little bit, just a tiny bit. We're going to keep the 4 as a 4 because he's a perfect square. This x to the 5th, we're going to break that up into x to the 4th times x to the 1st, right? That'll give you x to the 5th. And then you'll have a y to the 6th. So now what you're going to do, these are all factors, right? So take the square root of 4 and you get 2. Take the square root of x to the 4th and you get x squared. The square root of x to the 1st, that does not come out even, so he's going to have to stay underneath. The square root of y to the 6th is y to the 3rd, and then what gets left over? We had a square root of x. That x stayed there, and so that's the simplified radical down here. Sometimes you have to break things up a little bit to simplify it. So here's the summary. To take the square root of the even power, like x to the 8th, x to the 6th, x to the 8th, x to the y to the 6th, to take the square root of an even power of the variable, you're just going to divide the exponent by 2, right? That's all we did, divide the exponent by 2. All right, so we're going to take all of these roots down here that they're asking for. What we're going to do is divide the exponent, whatever the exponent is on these radicands, by n, and n is, remember, n is the index. It's the little number in the v. So here we go. We have an x to the 10th. Well, we're just going to divide 10 by 5. 10 divided by 5 is 2. And now we're going to divide 15 by 5, and 15 divided by 5 is 3. So that's x squared y cubed. Over here, we're taking the 5th root of 32. Well, if you forgot about the 5th root of 32, 5, math, option 5, the 5th root of 32, that's equal to, oops, you can't see my calculator. The 5th root of 32 is equal to 2. So the 5th root of 32 we'll write down as a 2. Now 3 being less than 5, we're going to keep him underneath. Keep as a radicand, because he's too small to divide out by 5. And then 25 divided by 5 is 5, so 2y to the 5th is outside, and then we're going to keep the 5 as the index, and we're going to have an x cubed out here. So sometimes you have to leave the radical like that if you can't divide it out. Now here's a cubed root of x to the 12th. 12 divided by 3 is 4. 15 divided by 3 is 5. Here's a 6th root. Well, now we have a case where 10 doesn't divide by 6 evenly, but it's bigger than 6. So we're going to split this up. We're going to split x to the 10th. And x to the 10th can be split up into, we're going to call it, excuse me, x to the 6th, because we want to match this radicand. Whoops, it's not the square root, it's the 6th root. So we'll do the 6th root of x to the 6th times x to the 4th, because x to the 6th times x to the 4th will give us x to the 10th. And then we'll keep this as y to the 6th. And now what we're going to do is we're going to take the 6th root of that one and the 6th root of that one, and that's going to stay in the radicand. So we have x to the 6th divided by 6 is 1. Y to the 6th divided by 6 is 1, and then what's left over is the 6th root of x to the 4th. We didn't circle that, so we'll leave it on there. So there's your final answer for number 4. The next one, we're going to do the 4th root of x to the 10th. We're going to split that guy up again in a different way. We're going to split. So x to the 10th, we want to make this 10 be some multiple of 4. So we're going to split it up to a multiple of 4 because 4 is the index. So we can split that up into x to the 8th times x to the 2nd, right? X to the 8th times x to the 7th will give us x to the 10th. And this is a 4th root. Y to the 20th, and 20 divides by 4 evenly. So 8 divided by 4 is 2. X squared comes out. 20 divided by 4 is 5. And then what stays underneath the radical? What is in the radicand? That is a 4th root of x squared. And then the last example for today, we're going to take a 4th root of 16. Be careful. A lot of people think the 4th root of 16 is 4 because you're just dividing, but you're not really dividing, really. You're saying what times what times what times what is 16? And if you want to take your calculator out, you can do a 4, math, option 5, the 4th root of 16, and you can see that that's equal to 2. So the 4th root of 16 will divide evenly. That'll give you a 2. Oh, we should probably split this out first because this y to the 14th we're going to have to break apart. So we'll keep the 16, x to the third. 3 is less than 4, so we're not going to split that apart. But y to the 14th, we're going to split this out into some multiple of 4. Well, y to the 14th is really y to the 12th times y to the 2nd. That's how that is split. So when we take the 4th root, we'll take the 4th root of 16 and call it a 2. We'll take the 4th root of y to the 12th and call it y to the 12 divided by 4 is 3. And then what's left underneath the radical? The 4th root of x to the 3rd and y to the 2nd, because we didn't split that apart yet. And that's it for today. I'll see you tomorrow.